Hello and welcome to this Tech Talk presentation on smart sensors and MEMS products, Omron's key components for the next generation. In this presentation, we will go over several of Omron's latest developments, including a time-of-flight sensor, environment sensors, and our MEMS product, the D6T Thermal IR sensor. My name is Cary Horan, the product manager for sensors and modules, and I will be going over the various different products throughout this module. Omron offers a wide variety of sensing components, which can be divided into three main sensing competencies. Optical sensors, or those using visual technology, include photomicrosensors, light convergent reflective sensors, and our newest time-of-flight sensor for 3D environment mapping. Sensing modules are more intricate products which include many different features in a single package. This includes our environment sensors, our sensor evaluation boards for product testing, and our human vision component module equipped with Omron's own facial recognition software called OCal. Omron's MEMS sensor products are our most expansive line, including pressure sensors, airflow sensors, and seismic detection sensors. In this presentation, we will focus on our Omron Thermal IR sensor, capable of measuring subtle changes in surface temperature of objects. The first product that we will discuss is the Omron Time-of-Flight sensor in the B5L product series. Omron's latest technology provides a solution for real-time 3D environment sensing. The product is capable of detecting stationary or moving objects, including humans, to be used in applications such as robot navigation or room monitoring for occupancy and person status. The sensor uses a time-of-flight method to sense distances of objects from the sensor using an LED array built directly into the device. The sensor differs from a conventional sensor by use of extensive distance information to identify the peripheral environment, as well as directly in front of it with close or far away objects. Using this technology to render a 2D or 3D image allows the sensor to be used in a wide variety of applications, including automated mobile robots, logistics and conveyance, human monitoring and observation, or automatic doors and elevators. This product has several key features and advantages, making it an ideal component for needs revolving around real-time environment monitoring. Compared especially with other sensors measuring time of flight, this sensor offers a high ambient light immunity up to 100,000 lux, meaning that even in the brightest of environments, including direct sunlight, the sensor is able to perform accurately and detect objects reliably. Its high precision technology makes it a sensor that can be relied on for navigation purposes, particularly in environments where objects may be lower to the ground and might not be detected by other competing sensors. Omron's unique hardware design allows the product to have a long working life. With its circuit design and heatsink, the sensor can run up to 5 years on continuous operation. Lastly, Omron has worked to prevent interference between sensors when there are multiple working in the same space. With Omron's design and software, up to 17 units may work in the same area without any interference in the field of view. The TOF sensor has several different advantages over the leading competitors in both ability and price, making it a perfect solution for autonomous mobile robot applications. 3D LiDAR sensors, historically used for these types of applications, also can perform well in how the sensor detects objects directly in front of it and in its periphery. However, these sensors can run a customer several $1,000s per unit, versus the much more cost-effective TOF sensor. 2D LiDAR sensors are much cheaper, but don't have the field of view offered by a sensor with 3D object detection. Objects that are too low or too high may be missed by the sensor. The Omron TOF sensor is not only affordable, but effective in detecting objects that other, cheaper solutions cannot. With a TOF sensor, the customer can be confident that they are getting a complete solution for only a fraction of the cost of the leading competition. On this slide, we will have a video demonstration of the sensor in action. If you refer to the image on the bottom right, we see the live camera feed showing the small office space where two people will enter and take a seat at the table. In the upper right-hand image, we have the video showing the distance of the objects in the room, including the people, from the sensor itself, providing an accurate view of the environment. Omron's 3D technology also allows for a 3D dot matrix image to be generated, giving the user a full rendering of the room, demonstrated on the large left-hand side of this screen. This next section will go over the Omron Environment Sensor, the 2J CIE product series, available in the 3 package types shown on this screen. The Omron Environment Sensor is an all-in-one package capable of measuring multiple environment characteristics simultaneously. Depending on the module that's selected, the sensor is capable of reading temperature, humidity, light, barometric pressure, noise level, UV index, volatile organic compounds or VOC levels, and acceleration. The sensor is available in the 3 packages shown on the image on the left: the USB version, the bag type version, and the PCB version. Each one is able to transmit data easily via Bluetooth, or in the case of the USB sensor, directly into a computer that it may be plugged into. Data can be read in a central database or via the free smartphone app for on-the-go monitoring. The data that is collected by the Omron Environment Sensor is useful for a wide variety of applications. In the office environment, the sensor can gather temperature, humidity, and light characteristics to create and maintain a comfortable working environment for employees. Similarly, in the home environment, the sensor can utilize this data to maintain a comfortable living space for guests and residents. This may be especially important for areas requiring specialized care, such as infant and elderly monitoring. The sensor can be linked to smart devices, such as central air and lighting controls, so that proper environment conditions are maintained whenever a person is present. For outdoor use, the UV sensor and the barometric pressure sensor in the bag and PCB type modules can be utilized to alert the user whenever there may be potentially harmful outdoor conditions. High UV levels may be damaging to sensitive skin, and sudden drops in barometric pressure may indicate approaching inclement weather. In commercial environments, such as a hotel, the noise level indicator and the VOC sensor may prove useful. Noise level indicators in rooms may alert the hotel staff of unruly guests, and the VOC sensor can detect cigarette smoke in rooms where no smoking is permitted. In a factory and industrial setting, the sensor can utilize the noise level sensor to ensure the conditions are safe for workers. Additionally, the accelerometer and the USB sensor can be used to monitor vibration levels and indicate to the user when there is unusual activity. This is especially important in areas where there may be earthquake risks. The sensor can be linked to emergency shutdown procedures so that if there is a high amount of vibration activity that could be potentially damaging to machines working with fuel or high voltage, The sensor may detect this and power down machines so that there is no further damage to the surrounding area. On this slide, we have two unique applications where we have successfully utilized the environment sensing technology offered by the Omron sensor. For sensitive environments, such as climate-controlled storage, the sensor can read environment characteristics to ensure that sensitive materials are being kept in appropriate storage conditions to prevent any damage caused by temperature or humidity fluctuations. Additionally, in shipping parts, the sensor can detect temperature changes, and the accelerometer equipped in the USB version can detect any unexpected movements that may cause further damage. In agricultural applications, such as a greenhouse or a plant incubator, Omron has seen much success with the utilization of the bag-type sensor product. The sensor can detect proper growing conditions of crops or flowers to ensure a healthy plant life with proper humidity, temperature, and UV detection. The sensors can be adjusted to gather data by the second, so it can constantly monitor problem spots that may be caused by poor air circulation or ventilation. The portability of the sensor also allows for easy transport in situations where a plant may be moved around a facility so that the most up-to-date data can be analyzed. The last product that we will go over is the thermal IR sensor in the D6T series. We have several products available that can detect surface temperatures of objects using our thermal IR technology. This sensor uses this technology to read the surface temperature of both stationary and moving objects. With this ability, the sensor is able to detect human presence even when a person is not moving. Depending on the module that is used in the D6T family, the sensor can measure multiple different data points within its field of view. Currently, Omron has available 1, 8, 16, and 1024 pixel count resolutions. The sensor gathers raw data which can be transmitted to the attached MCU via digital I2C output. Originally, this sensor was designed as a product to be used for general human occupancy in living or workspaces. In the illustration on the top right, we see a living room scene with two children reading in the corner. The sensor collects raw data from each pixel and outputs the information into a grid shown below. As we can see, the higher temperature outputs caused by the warmer temperatures of the people in the room indicate that a person is present, even as they are sitting still. On this slide, we will go over each of the sensors that Omron has available within the D6T series. Each of these sensors offers their own advantages in various different situations, including in the number of pixels output in the raw data, field of view viewing angle, and object temperature detection range. Recently, Omron has released newer high-temp versions of two of the existing products, the 4x4 pixel series and the 1x8 pixel series, allowing for more expansive opportunity in applications where higher temperatures need to be detected. Omron's latest version of the D6T sensor is the 32x32 pixel version, offering not only high temperature capabilities, detecting objects up to 200 degrees Celsius, but also a much more detailed picture compared to the other components in this part family. Further down in the table, we have an illustration giving a rough estimate of how the sensor field of view can appear when mounted from above. This helps show how data in an area may be collected by each available product. Keep in mind, sensors with a wider field of view may offer a larger area of room to be seen by the sensor, while those with a narrower field of view may offer advantages over longer distances. The illustrations here show how the field of view can look with a distance of 1 meter although the sensors may be able to work over much longer distances. At the bottom of the table, we see how a given image may look for each one of these sensors. As you can see, we have a much more detailed view of a person sitting in front of the sensor using the higher resolution 32 by 32 version, as each pixel is able to read the subtle changes in temperature over the entire scene. However, the low resolution 1x1 sensor's single pixel takes into account the average temperature of the entire scene. For this reason, the combination of the temperature of the person as well as the background temperature gives a single output of a much cooler scene. Applications using the 1x1 sensor can be effective, however, in applications where the sensor is much closer to the object that needs to be measured. In this case, customers may find the 1x1 sensor to be effective and much more affordable than the other higher resolution sensors in this family. These next slides will detail two unique applications using the D6T sensor. With the current pandemic affecting everyone globally, fever detection has been a growing need for gate access and building control applications. The factory settings of the D6T sensor are quite accurate. However, with customer calibration, these sensors can be tuned to detect temperatures down to the 10th of a degree, making it an ideal solution for fever detection applications. The sensor can detect the temperature of a person coming into a potentially crowded area and indicate whether or not they are exhibiting fever-like symptoms. This way, the user can help curb the spread of disease and sickness. In industrial applications, the sensor has been used in applications revolved around equipment monitoring, such as on power distribution panels. The sensor can be used to monitor equipment for unusual hotspots and indicate to the user when a component is in danger of overheating. In this way, the sensor can prevent any further damages to machinery caused by temperature malfunction. At Omron, we are committed to improving lives and contributing to a better society. We believe in the development of our sensor products in order to provide new technology and support ongoing production of new and innovative applications by the customer. I'd like to thank you very much for taking the time to listen in on this Tech Talk, discussing key innovative solutions Omron has developed to meet the needs of manufacturers today. For more information on these and other Omron offerings, including switches, connectors, power relays, and other sensor products that we did not discuss in this Tech Talk, please visit our website at components.omron.com. Thank you very much, and please reach out if you have any additional comments or questions.